ahead and start our warm-up today. We want to find the area of all four of the figures. What is this first figure up here? Number 1. It's a rectangle. What's the formula for the area of a rectangle? Somebody raise their hand. Yes, Autumn. Length times width. In this rectangle, what is the length? Zach? Almost. The length is 10x, and what is the width? Lawrence?
5x squared.
5x squared. So we're going to plug in 10x for L, and we're going to plug in 5x squared for W. We multiply our coefficients and multiply our variables. Who knows what our coefficients are in this problem? Lawrence?
The x.
No. The coefficient is a number that goes with the x. What are they, Grace? 10 and 5. Okay. 10 times 5 is what? 50. And then what are our variables, Lawrence? Give that one a try.
The x's.
The x and the
Squared.
x squared. So anytime we have x, it's x to the first power and x squared. When we multiply like bases, what do we do to their exponents? Autumn. You add the exponents. So 1 plus 2 is
3.
3. The answer for the area of this figure is 50x cubed. Now the triangle is next. Okay, what's the formula for the area of a triangle base? Base times height divided by 2. What's another way to write that? Autumn. 1/2 times base times height. Either way is fine. You can do it either way. Okay? So, what is the base of this triangle? 2x cubed is the base. And what's the height? 8x. Okay? So, either formula we put it in, we're going to get it. Okay, this one you'll probably see a lot more in high school. 1/2 base times height. The base is 2x cubed. The height is 8x. First thing we do is to multiply all of our coefficients. 1/2 times 2 times 8. What's half of 2? 1. And what's 1 times 8? 8. Then we have like bases, x and x. What's our exponent on this x? 3. What's our exponent on this x? 1. We multiply like bases. We add our exponents. 3 plus 1 is 4. 8x to the 4th is the area of the triangle. Questions on the first two? If we had said base times height divided by 2, we would have done 2 times 8 is 16 divided by 2 is 8. So either way, we get 8 for our coefficient. Let's do the last two. What's the area of a square? Lawrence.
Side times side or side squared.
Side times side or side squared. What is the side length in this figure? Somebody who hasn't answered yet. Aaliyah. 4x. So we take 4x, the whole quantity, and we square it. When we square that whole quantity, we have to square both parts in there. So we say 4 squared is 16, and x squared is just x squared. The next one is also a square. We use our formula side squared. What's the side length in this one, Caitlin?
6x squared.
6x squared. And we take that side length and we square it. What's 6 squared, class?
12.
6 times 2 is 12.
36.
6 squared means 6 times 6, which is 36. X squared squared. We have a base raised to a power, raised to another power. What do we do to the exponents? Multiply. 2 times 2 is 4. We have a power raised to a power. We multiply. Today's notes are going to be on computing perfect squares, perfect cubes, and fractions as exponents. Okay, we're going to talk about 2 special cases of fractions as exponents. We're going to talk about the other types of fractional exponents on down the road. First, you need to make sure you copy down these definitions. A perfect square is a number that can be expressed as the product of 2 equal integers. For example, 1. What 2 equal integers can 1 be expressed as? 1 equals 1 times 1. What about 4? What 2 equal integers can be expressed that one? Grace? 2 times 2. And so on. 3 times 3, 4 times 4, 5 times 5, all the way to 10. So these are your first 10 perfect squares. Okay, under that, you need to write the square root of a perfect square is an integer. The square root of a perfect square is an integer. Okay, the next part is a perfect cube. Perfect cube is a number that can be expressed as a product of 3 equal integers. For example, 1 times 1 times 1 is 1, or 1 cubed is 1. 2 times 2 times 2 is 8, or 2 cubed is 8. 3 times 3 times 3, or 3 cubed is 27, and so on. So, also under here, we're going to add something else. The cube root of a perfect cube is also an integer. So let's do several examples with computing square roots. The square root of 64. And that means there are 2 integers that you can multiply together to get 64. What is that integer, Lawrence?
Is it 8?
It's 8. What about the square root of 121? What integer can you multiply by itself to get 121, Joey? 11. And last, the square root of 169. What integer can I multiply by itself to get 169? Joey's already answered one. Does anybody who hasn't answered know what I can square to get 169? Herman? 13. Perfect. So the square root of 64 is 8. The square root of 121 is 11. And the square root of 169 is 13. Now let's practice computing cube roots. The cube of 27. What integer can I multiply by itself 3 times and get 27? Lawrence?
3.
3. 3. Okay. 3 cubed is 27. So the cube root of 27 is 3. What about 216? What's the cube root of 216? What number can I raise to the 3rd power to give me 216? Adam? 6. 6 cubed is 216. So the cube root of 216 is 6. Okay, before we move on to part C, are there any questions? Yes, Graylin.
Didn't you divide it by 3?
So the question is, if I don't know what the cube root of something is, can I divide it by 3? So if I have the cube root of 27 equals something that I don't know what it is, can I just divide 27 by 3 and figure out what it is? Okay? Now, let's think about that. If I divide 27 by 3, what do I get? 9. Is the cube root of 27 9? No. Okay? Now, if I was multiplying something by 27, then my inverse operation would be dividing. But I'm not multiplying something by 27. I'm taking the cube root. So I want to know what the cube root of it is. That means what number can I cube? What number can I cube to get 27? One way that's really easy to do it is to do it on your calculator. Now we all should know where the square root button is on your calculator. On your calculator, the square root button is underneath the square. So if I want 6 squared, I press 6, and I press the x2 button, that gives me 6 squared. What's 6 squared? 36. If I want an exponent, I can also use the caret button. 6 caret 2 will also give me 36. Okay? Second x2 gives me that square root. Second x2 gives me that square root. So if I want the square root of 36, it gives it to me. It's 6. One thing that we haven't talked about yet is doing the cube root on your calculator. Everybody get out your calculator. Press the math button. It's right under the alpha button. Press the math button. Oh, people not getting their calculators before class starts. Interesting. Okay, so once you press that math button, we have several different options. Okay? Option 4 is the cube root. Option 4 is the cube root. So if I want the cube root of 27, my calculator will give it to me. It's 3. Okay? I can check that. 3 to the 3rd power is 27. So let's see. The next one was, we had 216. So why don't we try the cube root of 216? The cube root of 216 is 6. The next one was the cube root of 125. Okay. So math 4, 125. The cube root of 125 is 5. What number can we cube to get 125? 5. So the cube root of 125 is 5. So no, good question though. You can't just divide by 3 because that gives you what you multiply by 3 to get 9, not what you're cubing to get 27. The next example. What is the side length of a square with the area 144? Make sure you're writing this down. What is the side length of a square with area 144? Now earlier we talked about the formula. What's the formula for the area of a square? A equals S squared. Okay. So what I'm going to do is I'm going to substitute in 144 for the area. 144 is equal to S squared. That means S equals what? What do I square to get 144? Lawrence.
144. Oh.
What do I square to get 144?
The sides.
Autumn.
Oh, 12.
S. What squared is 144? 12. Does the question make a little bit more sense now?
Yes.
What about the side length of a cube? Okay, the volume of a cube is side cubed. So we take our volume and plug it in for V. 729 equals S number do I cube to get 729? You try the cube root on your calculator. What's the cube root of 729? Oh yeah, 9. Cube root of 729 is 9. So the side length of this cube is 9. Last new thing for today is fractional exponents. An exponent of 1/2 is actually a square root. So x to the 1/2 power equals the square root of x. So anytime we have a root without anything on it, there's a 2 that we imagine there. Okay, so anytime we have a root without anything on it, we assume that it's a 2. Okay, so it's just a different way to write it. And then an exponent of 1/3 is a cube root. So x to the 1/3 power equals the cube root of x. Let's look at the next example. 16 to the 1/2 power. That 1/2 power means square root. So 16 to the 1/2 power is the same thing as saying the square root of 16. What's the square root of 16? Shayla, come on, go ahead and erase that for us. Still blank. 16 to the 1/2 power is 4. So what about 100 to the 1/2 power? Herman, what's 100 to the 1/2 power? 100 to the 1/2 power is the same thing as the square root of 100. What is it? 10. Perfect. What about 252 or 225 to the 1/2 power? Okay, Macy. 225 to the 1/2 power is the same thing as the square root of 225. What is that? Perfect. 15. Next, let's practice with 1/3 as an exponent. 27 to the 1/3 power is the same thing as the cube root of 27. Lawrence, what's the cube root of 27? What is it? Perfect. 64 to the 1/3 power is the same thing as what, Grace? What's the 1/3 power mean? What's the 1/3 power mean? Cubed root. Cubed root of 64 is 4. Perfect. And 343 to the 1/3 power. What's the 1/3 power mean to do, Preston?
I would do the square root of 3.
Not the square root. The 1/3 power tells you to do what?
Oh.
The cube root of 343. What's the cube root of 343? It's 7. Okay, your homework for tonight is 2 parts. The first part is to list the first 15 perfect squares. And find their square root. And that's the first part. So the first perfect square is 1. Square root of 1 is 1. What's the second perfect square?
4.
4. The square root of 4 is 2. The third perfect square is
9.
9. Square root of 9 is 3. I want So I want the 15th perfect square, and the square root of whatever of that is going to be 15. The second part of your homework is to list the first 10 perfect cubes and find their cube root. So the first perfect cube is 1. The cube root of 1 is 1. The second perfect cube is 8. The cube root of 8 is 2. The third perfect cube is what? 27. The cube root of 27 is 3. And I want that all the way through 10. The 10th perfect cube is 1,000. The cube root of 1,000 is 10. So we're doing the first 10, or the first, that's right, the first 10 perfect cubes and find their cube root, and the first 15 perfect squares and find their square root. You have about 20 minutes left of class to work on that, so you should be able to finish